Hello friends, now we will see rate measurer, how to deal with the problems of rate measurer. What is different from the earlier topics? We have to just differentiate with respect to t only. That is the thing. Rate measurer means with respect to time, at what time it is changing. So we have to just write the equation in the terms of the variables involved, just differentiate with respect to the t and we will get whatever unknown with the help of the known things. See in this question, a man of height 180 centimeters is moving away from a lamppost. Just draw the figure. This is a lamppost. Man is here. Lamppost light is coming from here and touching the ground here. So this is actually the length of shadow. We know this. And this is the distance the man is away from the lamppost. Whatever given things, we just write it in the figure and we try to establish a relation between the variables. So it is given the man's height is 180 centimeter and the lamppost height is 4.5 meter, that is 450 centimeter. If we are taking this in centimeter, we have to take that in centimeter as well. Otherwise, we have to take in this meter and this in meter. Okay. So we will establish a relation between this similar triangle and this. So it is coming out to be 180 divided by 450 is equal to x divided by x plus y. So this is 2 by 5 on cancellation with 9. So coming out to be 5x is equal to 2x plus 2y. So this is 3x is equal to 2y. Now we have established the relation between the variables x and y. What we have to do? Now just differentiate with respect to time. So it is going to give you 3 dx by dt is equal to 2 dy by dt. Now see, whatever is given, you put it and you will get the unknown thing. Okay. What is given here, we will see man is this. He is moving away at the rate of 1.2 meter per second. Moving away means the distance of the man from the lamppost is changing. So actually dy by dt is given and that is given 1.2 meter per second. So what is that? Dx by dt is 2 into 1.2 by 3. That is coming out to be 0.8 meter per second. And what is dx by dt? Dx by dt is x is actually the length of shadow. So dx by dt is the rate of change of length of shadow. Very simple. Once again I am telling you, establish the relation between the variables, differentiate with respect to t and you will get the unknown thing. Now see question number 2. A kite is 112 meter above the ground and 130 meter string is out. See here, kite is like this. This is the length of the string which is given here 130 meter and this is the height of the kite above the ground. It is given as 112 meter above the ground. Okay, and this is the horizontal distance of the boy from the vertical direction of the kite. So if we take this x, okay, and this is constant, this we take as y, this is constant 112, okay, dx by dt will give how horizontally the kite is moving and dy by dt will give you how the cord is laid out, how the string is laid out. So we have to just take x and y as variable because x is changing, horizontal distance is changing, the string length is changing, but the vertical height is remaining constant. It is remaining 112. So we have to establish the relation. What is that? X square plus 112 square is equal to y square. You just differentiate what it is coming out to be, 2x dx by dt. This is 0 is 2y dy by dt. So what we have to find, actually we have to find at what rate string is out. That means we are interested in that dy by dt. So what it is coming out to be, dy by dt is equal to x by y into dx by dt. Now see what is x and y. If it is 130, see, at a particular moment, when it is 130, this is 112, by Pythagoras theorem, you just write x square is equal to 130 square minus 112 square, that will come out to be 66. So at that particular moment, x is 66. So you just put it here, 66, y we got 130, and dx by dt, that means how horizontally it is moving, it's given. The kite is traveling horizontally at 8 meter per second, 8 meter per second. You just simplify this thing, you will get how the string of the kite is laid out, how fast it is laid out, the rate of change of the length of the string. Okay. Now see question number 3, water is dripping out at a steady rate of this through a tiny hole at the vertex of a conical vessel. The figure is like this. Okay, water is dripping out from here. Okay, and the vertical angle is 60 degree is given. So if we just draw the figure, this is coming out to be 30 degree, and at a particular moment we take this as r, this as h, this as l. We will just make use of the variables whatever is required in the question. Water is dripping out at this, so we are concerned with the volume. So volume of water in the filter at any moment is 1 by 3 pi r square h. Is it? Filter is this, find the rate of decrease of slant height. So we are interested in slant height only. So we have to get the value of r and h in the terms of L. Whatever required variables value we need, we just convert the other variables in the terms of that only. See here, if complete angle is 60 degree, then it will be 30 degree. So we can write cos 30 degree by Pythagoras theorem. You know what it is coming out to be? Base by hypotenuse. So the base is here h and hypotenuse is L. So we can get the value of h. H is what? L cos 30 degree. And same way we will get r is equal to L sin 30 degree. So we can just write RH and H in the terms of L only. So it will be 1 by 3 pi r square means L square sin square 30. Sin 30 is 1 by 2. So 1 by 2 square into H. H is what here? L cos 30. So L into cos 30 is root 3 by 2. So ultimately it is coming out to be 1 by, this is going to give you 1 by 2 square is 1 by 4. So 3, 4, 12, 2. That is 24. And here root 3. Here pi L cube. So very simplified version of this is like this. So we got the volume in the terms of the slant height only. Now you just differentiate with respect to t. So dv by dt is going to be root 3 pi by 24 into 3l square dl by dt. Now you see that dv by dt is given 1 cubic centimeter per second. So this is 1 is equal to, if you just cancel out, this is coming out to be root 3 pi by 8 into L square. The L at that particular moment is given when the slant height of the water in the filter is 4. So it is 4 square, that is 60 into dl by dt. So dl by dt is coming out to be 1 by 2 root 3 pi. L is what? Length. So centimeter per second. Just don't forget to write the unit centimeter per second. So you will get the rate of change of the slant height. In a nutshell, we can say we just write the equation in the terms of the variables, and if the variables are not there, we introduce the variable by appropriate modification with the geometry help. And after insertion of the required variable, we differentiate with respect to t, put the values of the known things, we will get the value of the unknown thing. Now we will solve certain particular problems which are very important and which will enhance your complete understanding of maxima and minima. See here in the first problem, show that semi-vertical angle of cone of maximum volume and of given slant height is tan inverse root 2. Firstly, we will draw the figure how to interpret the problem. See, it is a cone. Semi-vertical angle we are concerned about, that theta. Okay, what is given? Given thing is the slant height. L is constant and the variables are R and H. The first thing we have to write the term whose maxima or minima we have to deal with. We have to find the maximum volume of cone. So first instance we will write the formula of that is 1 by 3 pi r square h. As we have seen that we have to get rid of one extra variable, or we have to introduce the variable which we want to get. I am just removing one variable. What relation I am getting from this geometrical figure is L square is equal to R square plus H square. Okay, so if I get rid of R square, I will write this in the terms of H only. That will be L square minus H square into H. So we have just step number 1, writing the term whose maxima or minima to be found out. Step number 2, get rid of the extra variable. Step 2 is over. The third step is we have to differentiate with respect to the leftover variable. Now just little bit of simplification is giving us 1 by 3 pi L square H minus H cube. Okay, now step number 3, we have to differentiate with respect to H here, the leftover variable. 1 by 3 pi constant outside, it is L square, H is 1 minus 3H square. Okay, and step number 3 is that we differentiate and put it equal to 0 to get the value of the variable. So if I put it equal to 0, I will get L square is equal to 3H square, and L square, because we have to deal with tan theta. Tan theta involve R and H. See here, tan theta is perpendicular by base. So tan theta is R by H. So we are concerned about R and H only, because we have to get result that only. So we can just write it as R square plus H square is equal to 3H square. So we get H square is equal to 2H square is equal to R square. So we can just write R is equal to root 2H. So R by H is equal to root 2, and we see from the figure R by H perpendicular by base is tan theta. This is the semi-vertical angle. Complete is vertical, semi means half of the vertical. So this tan theta is coming out to be root 2, and you know that theta will come out to be tan inverse root 2. So the thing is proved. One thing we have to do, we have to double differentiate this to prove that at this value of theta or this value of R and H, the thing is maximum. So what we will do, we will just double differentiate this d square v by dh square. From here, double differentiate from here. Don't be confused. You just double differentiate and see what it is coming out to be. 1 by 3 pi constant, L square is 0 and that is minus 6h. So ultimately it is coming out to be negative, you see here. And if double derivative is negative, then the thing means V is maximum. Where? It is maximum here at this value of this thing. So the volume will be maximum when theta is tan inverse root 2. See in the next question. A open box of maximal possible volume from a square piece of tin of side A is to be made by cutting equal squares out of the corners and folding them to form the box. Okay, what is the geometrical interpretation of the thing? A square sheet is there. We are cutting square portions from all the corners, all the four corners, and just removing the cut portion and folding up the flaps, we will get an open box. We are concerned with the volume of that open box. Okay. We have to find the side of the square to be cut off. It's x everywhere, see, x. See, now after cutting off the square from the four corners, a box is formed. What will be the volume of the box? That is length into breadth into height. Why? Because that is going to be a cuboid. Okay, so the volume is length. What is the length of the box? Actual length was A, you know, it's given in the question. So we are cutting x here and x here. So the new length is coming out to be A minus 2x. Same way, new breadth is coming out to be A minus 2x. And what is the height? The portion which is coming up is just x. So we have done step number 1 and 2. What is that? Writing the thing whose maxima or minima to dealt with. We wrote it. Just getting rid of the extra variable, we did it by means of the geometrical figure, and just 2 steps over. Now what we have to do, we have to differentiate and put it equal to 0. On simplifying, it is coming out to be a square minus 4x plus 4x square into x. I just recommended go for a little bit of simplification. The things will be easier for you. Why? This is a minus 2x whole square, so a square minus 2ab 2ax plus b square, that is 4x square, and into x. So it is coming out to be a square x minus 4ax square plus 4x cube. Now very easy to differentiate. Differentiate with respect to x. The variable left over is only x here. We are getting a square. What is here? 8ax, because x square is giving you 2x. Okay, and this is 12x square, because x cube is 3x square. We put it equal to 0. We will get 12x square minus 8ax plus a square is equal to 0. So on factorizing this, it is coming out to be 12x square minus 6ax minus 2ax plus a square is going to be 0. So on taking 6x common here, this is x minus 6x we have taken common. This is 2x. This is 2x minus a minus, if I take here common a, this is 2x minus a. So x is ultimately coming out to be a by 6 or a by 2. A by 2 is not possible. Why? You just see, if we just write here a by 2 for x, the volume is going to be 0. That complete portion has been cut. So we have to pick up this value. Moreover, if we double differentiate this and put the two values, if we double differentiate d square v by dx square. Just double differentiate. This is coming out to be a square 0. This is minus 8a and this is 24x. Yes. So you put the value of a here. You at a x is equal to a by 6. At x is equal to a by 6. You just put x is equal to a by 6. This will be negative. What does this mean? This means that volume is maximum when the side cutoff of each corner from each corner is a by 6. So we have proved the thing. See, in question number 3, window is in the form of a rectangle surmounted by a semicircle. Just draw the figure. Shape of the window is like this. Rectangular portion and then a semicircular portion. Perimeter is 30 meter. Find the dimensions so that greatest possible amount of light to be entered. Just interpret the figure. If this we are taking as x, this is y, this is y, this diameter is going to be x. See, firstly we have to write the area of the combined figure. So, because we have to find the maximum value of the area, so maximum amount of light to be entered. So, A is coming out to be area of that rectangular, that is x into y plus area of the semicircular portion. What is that? 1 by 2 pi r square. R square. What is r? R is here x by 2. See from the figure. Because diameter is x, so radius is x by 2. That means x by 2 square. So the first step is over. Always write the first step whose maxima or minima to be dealt with. So I wrote it. Now I have to get rid of extra variable. How can I get? With the help of the given figure or the given conditions. See here, the total perimeter is given. The perimeter of the window is x plus 2y plus pi r, because complete circumference is 2 pi r and that is semicircular, half portion is there. So this is pi r. R is what? X by 2 is equal to given 30. See here, we are not involving this thing because the perimeter is like this, starting from here, here, coming here. So this is not to be included in rectangular portion. So we will just get the value of one thing. If I get the value of y, it is coming out to be 30 minus x minus pi x by 2 divided by 2. So I got the value of y, so that I can put it here, just making in the terms of single variable. Little bit of simplification will give us 30, 60 minus 2x minus pi x by 4. So y we got, we will put it here. So it is coming out to be x into y means 60 minus 2x minus pi x by 4 plus half pi x square by 4. So we got it in the terms of single variable x only. Little bit of simplification I am doing so that differentiation will be easier. So it is coming out to be, if I take 1 by 4 common throughout, I am just left with 60x minus 2x square minus pi x square plus 1 by 2 pi x square, because I have taken 1 by 4 common everywhere. Now you just differentiate dA by dx. So it is coming out to be 1 by 4. This is just 60 minus 4x minus 2 pi x plus 1 by 2 pi into 2x. That we have to put equal to 0. So we will just combine the x things here. It is coming out to be 60 is equal to 4x This is minus 2 pi x and this is plus pi x. So minus pi x, so plus pi x it will come out to be, and we will get the value of x here. X is coming out to be 60 by 4 plus pi. So we got the value of x and we can get the value of y very easily by just putting the value of x here. We got the dimensions of the window x and y because dimensions are being dealt with x and y only. Radius is also in the terms of x, so we'll get all the dimensions. One thing we have to prove, whether at this value of x the thing is maximum or not. So what we have to do, we have to double differentiate this. We will just double differentiate this d square a by dx square. We have done so many times in the previous question. You just double differentiate, put value of this x on the double differentiation thing, and this will come out to be negative. You will see, if this is negative, then a is maximum. Where it is maximum? At value of x this and value of y this, on putting the value of x here. So at this value of x and y, area will be maximum. Now see question number 4. A wire of length 28 meter is to be cut into two pieces. One is made a square and other a circle. What should be the length of the two pieces so that combined area is minimum? So first thing, we will write the combined area of circle and square. What is that? It is pi r square plus a square. Very simple. Now we have to convert it into single variable. So we will get help of the given thing. Given thing is that total length is 28. What means the total length? Total length of the square piece and the total length of the circle piece. The total length of the square piece is very much obvious, 4a, and that of the circular piece is 2 pi r. That complete thing is given 28. So we will get value of one of the variables. Suppose I am getting the value of a. A is 28 minus 2 pi r by 4. So I will get the equation in the term of single variable, that is r only. If I just write the value of a, this is pi r square plus a square means 28 minus 2 pi r by 4 square. So up to 2 steps we have done. We have to differentiate now, and on differentiation it is coming out to be dA by dr. What is that? Pi into 2r plus, just take help of the chain rule and differentiate it carefully. Something is square, so 2 into that thing is 28 minus 2 pi r by 4 into 28 by 4 is 0 minus 2 pi by 4, and that we have to put equal to 0. So what we are getting, see here, 2 pi r is equal to, coming out to be 2 into 28 minus 2 pi r by 4 into 2 pi by 4. Just I separated the things. This negative thing I have taken to that side, and now simplification is giving us this 2 pi is getting cancelled. So what it is coming out to be, if we just cancel here, this is 2, so 8 is there. So what is that? 8r is equal to 28 minus 2 pi r. So what is r? R is going to be 28 divided by 8 plus 2 pi. What I did here, I just brought r to this side, took r common. If I take 2 common, it is going to be 14 divided by 4 plus pi. So I got the value of the radius of the circle. So the length of the piece which is circular is not that. The length of the piece, circular piece is, length of circular piece is 2 pi r. So length of circular piece will be 2 pi, and r we got 14 by 4 plus pi. And the length of the square piece will be 4a. What is that? 4a. We will get the value of a from here, and we can just get the value of, or you can just write 4a is equal to 28 minus 2 pi r. Whatever value you got it, you will get. This is the length of the square piece and this is the length of the circular piece. This is not actually the length of the circular piece. But one thing we have to do once again, we have to differentiate, double differentiate this d square a by dr square, and at this particular value we have to check what it is coming out to be. You will see that is at this particular value, that means at r is equal to 14 by 4 plus pi will come out to be positive. You will see, you just differentiate, double differentiate this thing, put it r is equal to this thing, the thing will be positive. Once d square a by dr square is positive, that means a is minimum when r is this thing. So we got the minimum value of the pieces on putting the value of r like this. Rolle's theorem, where it is applicable and how it is applicable. We will see. I just named Rolle's theorem as 3 plus 1 theorem. That means if 3 conditions are satisfied, then the fourth will happen. What are these 3 conditions? See here. If a function is continuous in a comma b, what is that? Function is continuous in closed interval a comma b. If function is differentiable in open interval a comma b, and fa is equal to fb. If these 3 conditions are happening, then f dash x, that means f dash x, that means the value of x which is making its derivative 0, and that value we take as c. So we can say f dash c is equal to 0 and c should be between a and b. Then the Rolle's theorem is completely verified. So once again I want to say, if function is continuous, it is differentiable, f is equal to fb, then f dash c is equal to 0, and that c should be between a and b, and the Rolle's theorem is verified. So for the application of the Rolle's theorem, firstly we have to see whether the function is continuous or not continuous. You just see all the polynomial functions are continuous everywhere. They are differentiable. What we need to do? We need to just take fa and fb. Suppose question number 1, I want to take verify Rolle's theorem for fx is equal to sin x plus cos x minus 1 in 0 to pi by 2. We will see sine and cos functions are continuous everywhere. So definitely it will be continuous in 0 comma pi by 2. One thing you have to write, you have to just write that sine and cos is continuous everywhere. So this is continuous in 0 comma pi by 2. You need to write, don't skip these steps. It is differentiable. How? Just I am telling you a technique, very easy technique. You differentiate the thing. If you find f dash x, it is coming out to be cos x minus sin x. Why? Differentiation of sin x is cos x and that of cos x is minus sin x, and it is differentiable everywhere. What does this mean? Differentiable? Its derivative is defined at all values of x. What is derivative? F dash x. So it is differentiable in the given interval. So it is differentiable in interval 0 to pi by 2. This is open interval. In between that, closed means the external boundaries are also included. Now we have to check whether fa is equal to fp or not. Now fa, that is f0, is going to be sin 0 is 0, cos 0 is 1 minus 1 coming out to be 0, and fb, that is pi by 2. Sin pi by 2 is 1 plus cos pi by 2 is 0 minus 1 coming out to be 0. So FA is also equal to FB. So the first three conditions are met. So we can say that f dash x will be 0 and that value of x which we term as c will be between a and b. We will see it. Now f dash x is cos x minus sin x. We term that point as c. The value of x we take is as c. So f dash c, you just write c in place of x. So it is cos c minus sin c is equal to 0. We have to get the value of c. So it is coming out to be like that, sin c is equal to cos c. We can just write tan c is equal to 1. Why? Because I divided both sides by cos c here, so it is 1. And tan is 1 at 45 degree. So c is pi by 4. Definitely you see that pi by 4 is lying between 0 and pi by 2. So this pi by 4 is between 0 and pi by 2. So we can say Rolle's theorem is verified. So you just got how to write. Firstly write the continuity, then differentiability, then f is equal to fp, then just differentiate and put c in place of x, put it equal to 0 and get the value of c, and you see that the value of c is between the given interval. The Rolle's theorem is verified. In question number 2c, verify Rolle's theorem for ex sin x minus cos x in that interval. You see here e to the power x is continuous everywhere and sin and cos is continuous everywhere. So the product of e to the power x into sin x minus cos x is continuous everywhere. So it is continuous in the given interval. You need to just write it is continuous in the given interval, that is e to the power x sin x minus cos x is continuous in given interval pi by 4 to 5 pi by 4 is closed interval 3. Now if you just differentiate this thing, I said you, if you write fx is equal to this thing, f dash x is going to be e to the power x, differentiation of this is cos x plus sin x minus cos x. Differentiation of e to the power x is e to the power x. What I did here, I just applied u into v. I took this as u, that is v, and I differentiated. You see that this is defined for all values of x. Why it is defined? People just ask, how can you say that this is defined? This is defined because denominator is not coming out to be 0. The thing inside the even root is not coming out to be negative. No denominator is involved, so it is defined all the way. So we can say this is derivable in the open interval pi by 4 to 5 pi by 4. You just need to write that only. Now you have to take fa is equal to fb. So fa, that means f pi by 4 is going to be e to the power pi by 4 sin pi by 4, we know 1 by root 2, minus cos pi by 4 1 by root 2. Definitely it is going to be 0. All the time it won't be 0. In the earlier question we saw that fa was 0. It can be anything. It can be 3, fb can be 3, it can be 5, it can be anything, not necessarily 0. Luckily it is coming out to be 0 here. Now f 5 pi by 4, that is fb we are finding. Fb is e to the power 5 pi by 4 and sin 5 pi by 4 is minus 1 by root 2 and this is minus 1 by root 2 cos 5 pi by 4. Why minus? You know that it is lying in the third quadrant. In third quadrant, sin and cos both are negative. Ultimately it's going to be 0. So the first three conditions of the Rolle's theorem are met here. Now go for f dash x. F dash x We got it here. So f dash c will be, if you just write on simplification, it is coming out to be e to the power c cos c plus e to the power c sin c plus e to the power c sin c minus e to the power c cos c. This is getting cancelled. So what you are left with, 2 e to the power c sin c is equal to 0. As it is not 0, so we can write just sin c is equal to 0, where sin is 0. People say it is at 0 degree, but we have to find an interval between the given interval where the f dash c is 0. So at sin pi 180 degree also it is 0, so c is pi. Now definitely see that pi is lying between pi by 4 and 5 pi by 4. So pi is lying between pi by 4 and 5 pi by 4. So Rolle's theorem is verified here. See, in question number 3, we have to discuss the applicability of the Rolle's theorem for this function, mod function. See, fx is equal to mod x and the interval is -1 to 1. You will check by the basic continuity theorem that it is continuous. So we can just write it is continuous in -1, 1. Okay, if you draw the graph of this thing, no break is there. It is definitely continuous, not a problem at all. Now we have to check whether it is differentiable or not differentiable. So we have to break this function into its subparts, taking the definition of mod into consideration. So fx is coming out to be x if x is positive, that means greater than equal to 0. Okay, and it will be minus x if x is less than 0. So we got the value of fx after removing the sign of modulus. Now if we just differentiate this f dash x, it will come out to be 1 and -1 if x is greater than equal to 0, if x is less than 0. You just see that at x is equal to 0, it got different values. That means left hand derivative is not equal to right hand derivative. So it is not differentiable at x is equal to 0. At 0 is one interval between -1 and 1. So this is not differentiable. It is not differentiable at x is equal to 0. That means in the interval -1 to 1. It is not differentiable. So no question of applicability of Rolle's theorem. So Rolle's theorem is not applicable because the conditions are not met. So we can directly write Rolle's theorem is not applicable. See, in question number 4, it is given that function fx is equal to x cube minus 6x square plus ax plus b. Rolle's theorem holds. What does it mean? We need not have to prove that whether Rolle's theorem is applicable or not. We have to take it granted that Rolle's theorem is applicable. That means this is continuous, that is differentiable, and fa is equal to fb. We need to take the conditions as granted. So if we just write fa is equal to fb, that means f1 is equal to f3. This is giving us, if we put 1, this is 1 minus 6 plus a plus b is equal to fb. 3 we are putting, that is 27 minus 6 into 9, 54 plus 3a plus b. So we can get the value of a and b from the given conditions. Definitely you see here that b is cancelled out here. We will get the value of a. What is that? This is coming out to be -5 plus a is equal to -27 plus 3a. So it is coming out to be 2a is equal to 22. So a is coming out to be 11. Now we need to find FB. B, value of the B. A we got it because FA is equal to FB. Now F dash C. That means if we just differentiate this thing, this is 3x square minus 12x plus a. We just put the value of x because F dash C has to be 0. So you just put C is given 2 plus 1 by root 3. That is 3 into 2 plus 1 by root 3 square minus 12 into 2 plus 1 by root 3 plus a is equal to 0. If you solve, you will again get the value of a, which will be again 11. So the value of a is 11 we are getting. What we are getting, that b is getting cancelled out. B is not involved in the process of differentiation, and so we can say that it is applicable. It is verified for all values of b. So we can write that a is 11 and b is all real values. So we got the value of a and we got the value of b. Just we applied the Rolle's theorem and got the values. We will see Lagrange's mean value theorem today, shortly known as LMVT or mean value theorem. What the statement of the mean value theorem is there? Just see, if the function is continuous in a comma b, is differentiable in a comma b, then what we used to see in Rolle's theorem, continuous, differentiable and FA is equal to FP, but here two conditions are there, continuous and differentiable, then there must be a point between A and B where derivative at that point f dash c will be equal to FB minus FA by b minus a. What does this mean? Actually FB means value of function when x is b. So what is that if we write in this fashion, y2 minus y1 by x2 minus x1. So actually this is the slope of the chord joining the points a and b. So at that point tangent will be parallel to line segment joining the 2 points. What the geometrical meaning? See here, if curve is like this, 2 points are there, AB, it is continuous, it is differentiable, then in between A and B there must be a point where if tangent is drawn parallel to chord joining the points, it used to be parallel to x-axis in the case of the Rolle's theorem, but here it is parallel to line segment joining the 2 points. That is the basic interpretation of the Lagrange's mean value theorem. We can easily derive Rolle's theorem from LMVT. How? You see, if we just put f dash c equal to 0, it will fetch us with FA is equal to FB, which is one of the condition of Rolle's theorem. So we can say the very basic theorem is LMVT and Rolle's theorem have been derived from this theorem. Now see question number 1. Verify LMVT for sin x minus sin 2x in 0 comma pi. See, it is continuous function. Why? It is trigonometrical function. It is sine and cos is continuous everywhere. So it is continuous. We have to just write it is continuous everywhere. So it is continuous in that interval. That we need to write. It is continuous in 0 comma pi. It is differentiable in 0 comma pi. See here, closed interval and here open interval. Then f dash c. That means f dash x is coming out to be, you see here, cos x minus 2 cos 2x. So f dash c is here cos c minus 2 cos 2c is equal to, according to LMVT, FB minus FA by B minus A. That means F pi by pi minus F 0 by pi minus 0. So on simplification, it is giving us cos c minus 2 to cos 2c can be written as 2 cos square c minus 1 is equal to F pi. Sin pi is 0 minus sin 2 pi is also 0. So 0 minus sin 0 is 0, sin 0 is 0 by pi. So it is 0. So we are getting 4 cos square c minus cos c plus 2 is equal to 0. It is going to be a quadratic equation in terms of cos c. So we can get the value of cos c by the formula, quadratic equation formula, that is minus b plus minus under root b square minus 4ac by 2a. So cos c is coming out to be 1 plus minus under root b square minus 4ac, that is 1 minus 4 into 4 into, it is coming out to be 2 cos square c minus 1. So on expanding this 2 cos square c minus 1, it is coming out to be 4 cos square c minus cos c. So just expanding this thing, it is coming out to be 4 cos square c minus cos c minus 2. We just solve this by means of the quadratic equation. Cos c is coming out to be 1 plus minus under root 1 minus 4 into minus 2. So root by 8. So it is coming out to be 1 plus minus root under 33. Root 33 is 5.7 by 8. So this is coming out to be 6.7 by 8 or minus 4.7 by 8. Anyway, you just see the value is coming out to be between minus 1 and 1. We know that cos 0 is 1 and cos pi is minus 1. You see that the value of c is coming out to be between 0 to pi. Why? Because the value is between minus 1 and 1. So we can say that c is between a and b, that is 0 to pi. Very easy to understand. Cos 0 is 1, cos pi is minus 1, and the values whatever we are getting is between minus 1 and 1. So you just see that value of c is coming between 0 and pi. So between a and b. So LMVT is verified here. Now see question number 2. Verify LMVT for fx is equal to this thing in 0, 5. You see, this is a polynomial, and polynomial is continuous and differentiable everywhere. So definitely this function is continuous in closed interval 1, 5 and differentiable in open interval 1, 5. You just write continuous in 1, 5, differentiable in 1, 5. You need to write that thing all the time. Don't skip this step. Now f dash x is coming out to be 2x minus 2. So f dash c is 2c minus 2, and f dash c according to LMVT will be equal to fb minus fa. That means f5 minus f1 by 5 minus 1. You just write the value of f5. What is that? 25 minus 10 plus 4. Minus f1 is giving us 1 minus 2 plus 4 by 4. So we can write 2c minus 2 is equal to, coming out to be 25 minus 10 is 15 and plus 4 is 19 minus 5 minus 2 is 3 by 4. 16 by 4 is 4. So C is coming out to be 6 by 2, that is 3. And see that C is between 1 and 5. So C is between 1 and 5. 1 and 5. So we can say that C is lying between A and B. So LMVT is verified here. And we got the value of C for the LMVT here. Now see question number 3. Find the points on parabola. This way the tangent is parallel to chord joining the given points. See here, we can apply LMVT here very easily. Why? This function is continuous and differentiable in the interval 3, 4. This is A, this is B, this is FA, this is FB, y coordinates. Okay. So it is continuous, differentiable. That means f dash C will be equal to FB minus FA by B minus A. So f dash X here is coming out to be 2 into X minus 3 into 1. So f dash C is 2C minus 3 is equal to FB minus FA by B minus A. Or you can write, we have seen y2 minus y1 by x2 minus x1. That is the slope of the chord joining the points. So what is that? y2 minus y1 by x2 minus x1. So it is coming out to be 2c minus 6 is equal to 1. So c is coming out to be 7 by 2, that is 3.5. Okay, you can just write 7 by 2. Now C is the value of x coordinate. If we need to find, we got the x coordinate. We have to get the value of the y coordinate from the original equation. So y coordinate will be equal to x minus 3 whole square, that is 3.5 minus 3 whole square. That is 0.5 whole square, that is 0.25. So you can write 1 by 25 like that. 0.25, that is 1 by 4. You can just say. Okay. So the point where the tangent is parallel to chord joining this and this is, point is always in the form of x comma y. X coordinate is 7 by 2 and the y coordinate is 1 by 4. So always keep in mind that whatever value of C we are getting is actually the x coordinate. Wherever required, we can get the value of the y coordinate by putting that value of x in the original equation.
Increasing and decreasing function. A function can be determined whether it is increasing or decreasing with the sign of its derivative. Suppose a function is something 2x square plus 1 like this. Okay, we have to determine in which interval it is increasing or decreasing. You just keep a rule in view that when f dash x is positive, function is increasing. When f dash x is negative, function is decreasing. Okay, for this particular function, if I have to check, I will find f dash x, which is coming out to be 4x. So this will be positive. 4x will be greater than equal to 0 when x is positive. That means for all positive numbers, this function is increasing, whereas for negative values of fx is less than 0, when x is less than equal to 0, the function is decreasing. So this, for this values of x, function is increasing, and for these values of x, function is decreasing. This is the most simple way how to check a function is increasing or decreasing. One more example I am taking. See, if fx is equal to sin x, you see, So to determine whether the function is, if I have to check in 0, pi, whether it is increasing or decreasing, I'll find its derivative, which is coming out to be cos x. We know that cos x is positive in first quadrant. That means in 0 to pi by 2, cos x is positive. That means in this interval function is increasing, and we know that in second interval cos is negative, so in the interval pi by 2 comma pi it is decreasing. Okay, I am taking one more example to check the interval where it is increasing or decreasing. If fx is 3 by x plus 7, anything like this, we have to check whether it is increasing or decreasing, in which interval it is behaving like that. So if I am finding f dash x, it is coming out to be minus 3 by x square plus 0. See, x square is always positive, so it is minus 3 into something positive, always positive, because the square of any number is always positive. So it is negative all the time. X belongs to R. For all values of R, x in R, it is negative except at 0. Because at 0 it is not defined. So this function is universally decreasing for all values of x except x is equal to 0. One more example I am going to take to check the interval where it is positive or negative. It is fx is equal to x by x square plus 1. So firstly I have to find f dash x to determine the points of increasing or decreasing. So f dash x is coming out to be, it is in the form of u by v, v as it is, differentiation of u is 1 minus x as it is, differentiation of that is 2x by x square plus 1 whole square. So it is coming out to be, on solving, this is 1 minus x square by x square plus 1 whole square. Okay, so to check the function's interval where it is increasing or decreasing, if I am checking for increasing, you see 1 minus x square by x square plus 1 whole square should be greater than equal to 0. This can be neglected. Why? Because square of a number is positive and positive thing can be neglected. So actually it is 1 plus x into 1 minus x. Okay, this can be further written as x minus 1, x plus 1 less than equal to 0. So we will see where it is positive or negative. The critical point is minus 1 and 1. You just write it here. First interval positive, second negative, third positive, like this. It is minus infinity, this is plus infinity. So if I have to check where this thing is negative, this thing is negative in this interval. That is minus 1 to 1. Minus to 1 to 1, this expression is negative. That means that f dash x is positive. So in this interval it is increasing. So increasing in when x is between minus 1 and 1. And same way we can find this function to be decreasing here and here. So easily we can find the points in the interval where the function is increasing or decreasing. You just proceed in this way. You can solve the problems of increasing decreasing functions very easily. tangent and normals. We will see geometrical meaning of dy by dx. Okay, if a curve is represented like this, x square plus 3x plus 4, I'm just taking one example, then derivative of that curve dy by dx, which is coming out to be 2x plus 3, is actually the slope of tangent. Slope of tangent. So if we have to find slope of tangent at any point on the curve, suppose a point is x is 1 and y is something, if we put 1 here, 3 of 8, 1 comma 8, it is coming out to be 2 into 1 plus 3, that is 5. So the slope of tangent to this curve is 5. Okay, if we have to find the slope of normal to a curve, normal is a line perpendicular to the tangent at the point of contact. So slope of normal is negative reciprocal of slope of tangent. So it is coming out to be minus 1 by 5 here. Just see, if a curve is like this, this line is tangent, then this line is normal. Okay, if you just draw x-axis and y-axis, and this is the point of contact where the tangent is drawn to the curve, you can find that point of contact by the given conditions in the question. Now if you have to find the equation of a tangent, then it is coming out to be, as tangent is a line, we know that equation of line is y minus y1 is equal to m into x minus x1. So for this particular question, I have to find a tangent at 1 comma 8, then the equation of tangent will be y minus 8 is equal to slope we got 5 into x minus x1 is 1. This is tangent. If we have to find equation of normal at this point, it will be y minus 8 is equal to minus 1 by 5 x minus 1. Very easily you can find equation of tangent and that of normal easily. Now if we have to find angle between two curves, actually curves are not making angles, we are dealing with the angles what the tangents are making between them. So if two curves are there and their slope of the tangent at a particular point are m1 and m2, then angle between the two curves is taken as m1 minus m2 by 1 plus m1 m2. Okay, I'm just taking one example. One curve is y is equal to x square minus 5x and another is y is equal to x cube minus 2x plus 3, like this. So if we have to find angle between two curves, we need to find the slope of first curve, slope of the tangent to the first curve. We have to find the point of contact. How can we find the point of contact? By simultaneous solving the two equations. If we are getting m1, the derivative of this thing, it is coming out to be 2x minus 5. Suppose the point of contact is alpha comma beta, then the slope is 2 into alpha minus 5. Don't be carried away by the term alpha. Point can be 1, 2, 2, 3. Like this you put it, you will get the slope of tangent to the first curve at that particular point. Same way you get the slope of the second curve, which is coming out to be 3x squared minus 2. So M2 at the point alpha comma beta will be 3 alpha square minus 2, like this. And we can find the angle between them easily following this. So for finding the angle between two curves, just follow the steps. Firstly find the point of contact, then find M1, M2 at that point, and then find the angle following this formula. Two curves are said to be cut orthogonally if angle between them is 90 degree. If tan theta is 90 degree, that means 1 plus m1 into m2 is equal to minus 1. So we get m1 into m2 is equal to minus 1. So two curves will be said to cut orthogonally if derivative of first curve into derivative of second curve, this is of first, this is of second, their product is minus 1, then the curves are said to be cutting orthogonally.